Hello, everyone. Thank you for coming. How you enjoy the Code Europe Festival? I enjoyed personally very much. Have you been to yesterday's concert, perhaps? Yeah? Yeah, I enjoyed too. This is a little bit of small talk just to break, just an icebreaker. It's mainly for me, not for you. You already know this drill. Yeah. Let's maybe first with introducing myself. My name is Marcin Kropacz. I am a data-oriented specialist, and I work for several years in different roles, in different data-oriented roles, both as a data scientist for most years, and recently also as a data engineer. I know a thing or two about the data, I've seen a thing or two about the data, and there's nothing, so it's not surprising about that I work for Asaisoft, for a company that is also data-oriented. Asaisoft is working in several industries, varying from healthcare to fintech. Yeah, but today we are not talking about me, myself, neither we're talking about Asaisoft. Today we are talking about large language models, which I believe is a topic of at least like 60% of lectures today. Yeah, this stuff that everyone is talking about, and there are good reasons for that. I know maybe this is my just information bubble, but when the guys from accounting start talking about large machine learning models, you know that something is going on. So as an engineer, I would like to lead you through my process, and I would like to share the process that we go through within our Asaisoft for the past few weeks. So we'll start with a vision of an end product, of an application that actually utilize large language models like ChatGPT. And when we start, we will see what is this actual our goal for us. What is the end product, what we can achieve. This will be a really simple example, but the main clue of our today's talk is how to actually achieve something like that. There are several ways to approach implementation of applications that utilize large models, like ChatGPT, and not every way is for everyone, of course. We will focus mainly on two approaches. One is to just rent your model. There are several providers that can do that, and is probably the most popular option right now. But there are some concerns. So in concerns, this option is really not for everyone, and I will tell you why. And we'll turn to another option, which is self-hosting your models, which, as you can lead from the title, we have the most knowledge to brought to discussion as Asaisoft. We can share our findings that come from a few past weeks of playing with that. And we'll try to introduce also how to fine-tune the models, how to fine-tune really large models or really not so big infrastructure. And we'll show you what is like cost and opportunities that are granted by utilizing such models. Okay, I will also inform you what this lecture is not about, so you know what you are actually signing up for. So I'm not going to introduce you to the concept of large language models. So, because unless you've been sleeping under a rock for the past year, yeah, you heard about ChatGPT, you heard about some really amazing stuff that it can do, from generating some amazing graphics to screwing your kid's English teacher by generating the entire romanticism essay for the classes. And yeah, we all know what is going on right here. I'm not talking about history of large language models. I don't think that there will be much of interest for that. And I will not detail any particular algorithms that are used to train such models. This is too deep stuff. It will take like entire semester of course in academic terms. And yeah, I'm also not the best lecturer for that purpose. And I'm also not selling you any product. We just want to share a framework that we come up with within our company. So think about this like kind of one-on-one for how to use LLMs in practical context. Like I said, we are starting with a little demo. I will play you a short recording of our CEO using our application. This application has kind of interesting context. It's something very usable, in my opinion. We will be using this large language model to navigate through large documents, some kind of wiki. And you know, if you are IT, I'm sure you encountered a problem of like overgrown Confluence pages that nobody can really get through. So what is your next intuition to do? I'm sure it would be to ask someone more experienced, like someone who already read it, or yet better, someone who wrote the entire thing. But yeah, the time and the patience of those highly experienced individuals is a finite resource. And we shouldn't really play with that too much. So it would make sense to have just a kind of application with form of a chat that could be implemented in your, let's say, Slack or Discord, that you can ask about the specific content of the large documents, and then we will be provided with exact answer based on the very paper that is topic about this conversation. So now I will play you the short clip of our demo.
What is the problem statement of LORA?
The acronym stands for leadership, organization, or operations. It refers to how these three areas work together within your organization.
What is the problem statement of LORA?
The goal of LoRa is to reduce the amount of computation required while maintaining high accuracy on large data sets, e.g., billions or trillions of examples. It does so through two key ideas: weight sharing across related tasks.
Okay, I think we can stop by now. This won't get any more interesting. As you can recall, we got models presented with the same question twice. And the difference in the response was quite severe. To say, this is only the issue of how we are actually providing the model with actual informations. In the first sense, we got only the trained model. And in the second example, we got also a trained model, but the model was also provided with not only the question that user has asked, but also a prompt that was embedded in special way so model can understand, so the model could also utilize this information. So this is a way of actually embedding and leveraging all the data and knowledge bases that your company have clearly gathered through its existence. And yeah, as you can see, the model is working. You can actually talk with that. We have implemented also text-to-speech and speech-to-text, but at this point, this is only like kind of a user experience thing. Like this does not provide like any excitement for any of us anymore because we have seen so much in past months. But most of those applications that we have seen that really like go viral through the internet are not really applicable. There is, for example, something about the model that could write a rap song about ducklings. Yeah, it is funny, but unless you are like a rap artist with an audience who is particularly enthusiastic about ducklings, which can't mean, then this is not really applicable. And this is something that we can actually leverage. And the question is now how it can be implemented. So we got several options here. First of all is to not implement it. And not entire thing, but by this I mean the very model. So the first option is to rent this. There's already many providers. Just one example is OpenAI that can grant you the access to the API of ChatGPT 3, ChatGPT 3.5. And even train a custom version for you if the price will be right. They will be more than happy to do it. So the only thing that would actually have to do is to set a web interface where the user can actually communicate with the thing, and of course some backend that will utilize probably your actual knowledge, and then you send embedded informations to the model API that actually leverages the information provided by the model and provides the answer back. But if you think about this just for a moment, there's clearly some issues going on here that in the enterprise environment could really go wrong very fast. There are a few options. The biggest one for us as a Asisoft was data security. As I mentioned, most of our clients is from the healthcare and biotech industries, which are very sensitive about the security of their data and their privacy. For their cases, in most options, there is no talking about sending the data in some place that is not visible for us, and we have no transparency how the data is handled, and we have no information if there was a leak, and if, there may be a leak, and we will know about it months later, which is simply not acceptable for most of them. Reliability of model answers is also an option, and not an option, but also an option that could go wrong. The quality of the answers is something to be controlled with, especially in the situation when your model is public-facing, like you users from the entire world can ask it, for example, about your company. Maybe you are implementing HR model that will help recruitment and will answer the basic tasks, just to not like take some effort from your actual recruiters. And in that case, if you got the model that you are not sure of responses on how model will actually behave, we are actually talking about how the model is talking with someone. If the model will be rude or biased in some ways, like this could be a real issue. Issue of course, of human dignity, and also a PR issue for you. And those are not really cheap. May I remind you? Everyone in this audience will surely remember some chat of Microsoft who went wild on Twitter, and how it ended. Let's better not talk about it. And there's an issue of cost, of course. And those things are not cheap. In some very particular cases. And the OpenAI, in this particular example, can cost you up to 60 cents for even one request. So this is not going to scale well. And the issue of legality. For example, the data that you are feeding to the model may be geo-restricted. Maybe you don't want to send the data because you are obligated by your client to keep the data on the European continent, on the North America region. That might be an issue. So if you like anything like us, these are the things that you at least have to consider while implementing such a model. And a response to that may be, of course, to host model yourself. You will have full control of the data. You can be really transparent about where the data is and be really sure that nothing is going wrong with them. You can take care of security yourself. And you are more in control of the very model. You are actually able to fine-tune the model to your specific case and just play with that, make as many iterations as you want to, and though have more reliable mode of availability, meaning you are in control of your infrastructure, so you can make sure that it's actually available to the client, and also reliability of the answers. So should we train our model from scratch then? Unfortunately, no. And there are very good reasons for that. Like large language models of the scale that we encounter now in the internet are something that is not affordable for the most of companies. Models of the size like ChatGPT cost millions of dollars to train. I'm only talking about the infrastructure cost, not talking about like data scientists that you have to hire to build the entire thing. Those guys are not cheap, I should know. And those guys are hard to come by. There's not many people in the world that could explain you in detail how to train model with attention, how to train transformers, how to actually implement that. So even the models that are smaller will cost you millions of dollars on the cost projects, but may be good for some. But let's remember that training a machine learning model is actually an iterative process. So there will be not only one situation when you actually train the model. There will be several of those until the end effect is satisfying to you. But luckily, there's an alternative. And this alternative is really a game changer that I want to kind of sell you here, let's say. This is open source. This cannot be sold, at least in that context. But yeah, there's a game changer that have emerged in the recent weeks. And there's always been some open source models that are available for everyone. Models you could just download on your own computer and run on your own infrastructure. But there is also the issue of the licenses. Not all open source licenses are created equal. And not all of those grant you the permission to use model in a commercial context. And what has happened in recent months is the resurgence of models like Mosaic MPT-7B or OpenLlama and models like that are actually suited legally to be used in commercial context. And this is a big deal, simply because you can just grab it out of the box. Some of those models are actually ready to be used from the moment that you download them, and then the actual infrastructure that you deployed in is pretty similar to the standard IT operations. We got some repositories or some kind of orchestrating that. There will be some Kubernetes space that will orchestrate your clusters. Cluster itself, of course, there will be probably powered by GPUs, and they are usually much more expensive, but they are available. And the difference is not that big anymore like it used to be. And of course there is storage, but storage nowadays is quite cheap. So it doesn't make much sense to worry about it in this context. This will not make a difference. And in this context, I would like to focus on a very particular model, which is Mosaic ML-MPT. Mosaic is a machine learning-oriented company that in the first weeks of May released MPT model. And this bad boy comes in several flavors. First, you got your standard base model that is just pre-trained, very big transformer model. And it is not ready to be deployed, but it's a very good template for your particular cases. If you want your model to behave in a certain way, there will be a starting point. We also have an instruct model that can generate instructs, and this is a model you can actually talk to. We get chat model, and this one is not in particularly of interest of us because this one is in fact not commercially available. And there's also storyteller that is really fun, but yeah, not very much of commercial applications either. And those models are relatively small. Relatively, those models are around 7 billion parameters, which might seem a lot, but let's remember that ChatGPT version 3 and 3.5 had around 180 billions of parameters, so the scale is quite considerable. But this model is also fine. The model that we've been talking on the demo is actually created based on that model. And what you are getting for basically free is actually quite a lot, because those models, which the very cost of the infrastructure it was trained on is around 200,000 of US dollars. That is at least what Mosaic claims, and I don't claim they are wrong, but I'm very curious about the cloud provider and how they got such a deal. We tried to set up similar infrastructure. It was not that cheap, especially that this training took almost 10 days to complete. And this is everything that you get for free. Let me make one thing clear. I'm not paid by Mosaic. I'm not in any way associated with Mosaic, and neither is ASISoft. I'm just really excited about that. And that's why we're talking about. And there are factors to consider, but because you may wonder if the model like this, that is relatively smaller than relatively tiny to the prospects of, let's say, ChatGPT, is even applicable for me. It doesn't seem like much. But yeah, I would argue that there is a case for small models, because for most of the context, you don't really want to write rap songs about ducklings or essays for your English classes. You want to have a simple conversation and ability to search a large amount of data quickly. And this is something that even those small models can do really well. So, and if the model is really small, this is something that your company can actually handle. Like the cost of infrastructure to hyper-tune and fine-tune this model is something that could do with relatively modest cost and relatively modest hardware. And we'll show you how to do that within this presentation. This will also allow you to better suit the actual model and for your use case and possibly scale. You can have several of those online at the same time, and do not worry about them costing you actual millions of dollars. So this is how we set up the basic infrastructure for fine-tuning the model. This is exactly the data and the model that you have been seeing on this demo. So first of all, we used Mosaic MPT7B, which stands for 7 billion base model, and this is available on a Hugging Face. And this is also a data set provided by the same company that will allow you to train this model to the form that you can actually talk with. This is all commercially available and free on the Hugging Face right now. And they also provide you with the scripts that will orchestrate the learning itself. The only thing you have to worry about is actual infrastructure, which we gathered on the Fluid stack. And this issue of infrastructure is actually not so trivial right there. This is still a complicated process because when you're operating a large number of GPUs at the same moment, in this context, we only made MVP, so it wasn't that big. We only 8 commercially available GPUs, but if you are training it for the larger case, you might need even dozens of those. And you may still need to orchestrate. For example, if you got dozens of those, I'm practically sure that within training, some of those machines will come offline. And you don't want to lose your results, especially if you already paid for like 7 days of those machines actually running. But the very process from the machine learning and data science point of view is no longer that complicated. We simply want to fine-tune the model on the data set we gathered. We conduct validation to make sure that model is actually doing what it's supposed to be doing. We're saving the artifacts, and the model is ready to be hosted. And now the cost. This is actually rough calculation of what we have actually done to produce model that you have seen in the very beginning. So we got data set of 60K entries, which is relatively small, and it takes around 7 million tokens in this. And to put a number on that, which is actually pretty hard, but we got actually about lucky because we used a lot of spot instances, and training of this particular model cost us about $100. I'm not talking about thousands of dollars, I'm talking literal $100 to train such a model from the scratch in the infrastructure costs. And this is to be compared with cost of model as a service that can be provided to you by, for example, OpenAI, which does not welcome you with any like costs to actually buy a license for that. You're paying generally for the actual request that you are getting, but it oscillates around 60 cents to even $1 for actual request. There's a lot of numbers here, and yeah, you could. This presentation will be provided to you later. But fine-tuning that OpenAI also provides for this particular data set and this particular model, which will be around $250, which is also not so much in this small context, but this is something that is comparable yet, and the handling cost, the cost of the infrastructure that you have to have to actually run the model in the production environment are very hard to estimate, but we'll give you a rough estimation of what it is. So this is just reaffirmation of the learning process that we done. It took around 2.5 hours to provide us with the model that you have seen, and we used 8 GPUs, 100, I believe, which for the cost of the actual running that, we don't need that much of infrastructure. The infrastructure that you need for training is usually orders of magnitude larger than the actual machines that you are needing for the actual production. But the issue is about how do you host it and how much of user you usually have, how do you scale it. This can really differ, so that's why it's difficult, and it's hard to calculate what is actually cost per particular request to be made. We'll give you a rough estimate for that. That the cost is, it's maybe not always cheaper to actually request, but the cost is still comparable. And there is no definitive answer for that. The OpenAI may be still a better option for your case. OpenAI is really easy to use. You don't have to train anything. You don't have to host it. You don't have to have infrastructure to actually host this. But it will go with the concerns that we mentioned previously. You don't have control over your data you're sending. Maybe you cannot train. And if the cost is of those is comparable, then in that context, the issue that you gain, which I mean control of the data, is something that, at least for us, is worth the actual effort to host on our side. And this is probably the way that we will be handling it. So, few conclusions before we go to the Q&A sessions. This is a good news from my perspective to you. LLMs are more available and cheaper to host on your side than they ever been. And this is great because they're just tools, and they're great tools, and they could be utilized to bring the value to your company, to your customers, to automate your work and make your life easier. The very process of hosting it, operation-wise, is not very trivial. You will still need to have some data scientists on site. You will still need to invest something in infrastructures. But yeah, these costs are roughly the same as the usual cycle of software development, which is something new. This used to be of a different level of magnitude previously. And thanks to that, you allow more trial and error. You simply can afford to try something different, to try something cool, maybe something that would be inspiring for the others. This is actually a great opportunity for all of us. And thanks to these advances, you will be more on control of overall process and overall system. So, to summarize, host or rent? I cannot tell you that. I don't know your actual use case. But yeah, I think that the process we can guide you with and the points to consider might be pretty useful when you stumble upon such a question, and you will stumble upon such a question if you ever want to utilize such models. And I will simply want to present you with the options. You can, okay, what's more? Okay, fine-tuning. Fine-tuning is now that affordable that can be utilized with very modest budget and can be handled even by very small companies, so everyone can experiment. And the last thing I want to leave you with is that if you still don't want, you still have questions on how to do that maybe we, as iSoft, can help you with that. So if you got any questions, we're waiting for you in the booth 39, and we will be trying to help you as much as we can. So now I will dedicate like 15 minutes if there are any questions regarding what I have just said. Anything? Yes, please?
How many instances of your model can you run in parallel on the single GPU, and how does it compare to usage of open AI solutions?
Like I said, it is really different to actually test models in inference mode when you actually try to make some predictions and some answers. And to be honest, this issue is like a few weeks old, so we are still trying to test that, and I don't want to provide you with a false answer, so I will not give you the number. But yeah, what I can say tell you that it is practically not possible to run multiple models on the single GPU. You will probably want to scale instances and nodes with entire infrastructure to provide additional models. Any more questions? I have seen something there. Yeah, please.
My question is about infra and maintenance cost. So first of all, thanks for presenting the nice things, because now I'm working on this particular project, so in my organization. But my question is like, you showed an interesting metrics, like let's say cost, $100 versus $210, I guess. It's a quite fascinating and interesting. Looks like it's a super cool and cost efficient things. But my question is, did you ever consider on your own infra maintenance and infra setup cost versus this cost, or only you just consider the infra cost only?
Yeah, we made like our calculations were in two categories. First of all was the infra of cost actual nodes that were used to run actual GPUs. And the second category was to entire infrastructure, the whole Kubernetes cluster and everything, monitoring, etc., or CI/CD that was involved in. Guys, can you help me with the actual number? I'm quite sure that this $100 was only for the actual GPUs. How was the cost for the rest of infrastructure?
And also like maintenance cost, because it's a really fascinating thing, because it's like huge number. You are saying that only 100 versus 210, it's not like this. It's like double and like almost 50% down the cost. But I believe there is also, we need to consider about infra cost and infra setup cost and also infra maintenance cost. So it should be considered there. Because if we use the OpenAI, we don't need to think anything about it. It's like serverless like things.
Okay, there is an additional issue process-wise to the very like process of training. Process of training is not something you like do that is constantly running. Your model are trained once and then you host them. So there's no actual maintenance in that context.
But itself the infra I have to maintain, because if I maintain it on my, let's say, ecosystem, then it should be up and running whenever I need to train the model, right? Or whenever I need to serve the model. So I need to ensure from an infra perspective that this system is up and running, the data scientist can use anytime. So in this case, we have to consider like.
Can I have a mic? Sorry guys, but I just want to support here.
Yeah, thank you.
Yeah, so on this one, the thing is that we were skipping for the presentation the cost of infrastructure. If you need to run this with OpenAI, the cost of infrastructure is quite similar. We wanted to focus only on the GPU usage. And this assumes that you're using it full time, basically. So of course, but the setup we have is that you have a separate node pool of GPUs. So we use Kubernetes, so it uses the autoscaler. So when you're not using GPUs, it will go to 0. And thanks to Kubernetes, you will be able to leverage your costs, right? But the benefit is that if you start training or inference, the nodes will go up, and basically you can keep on going. And this is just a matter of, whether you're doing inference and just running the code, or you're using it for training, two different cases, right? So for this, from the infrastructure perspective, we focus only on the GPU aspect of it, okay? Yeah. But we can talk later.
I have
Well, it is the cost of the infrastructure, but the more requests you have, it will grow.
Then maybe the comparison itself is like somewhere in like to me is like misleading because the thing is like.
Yeah, in the end, we wanted to make some clear conclusion as well that if privacy is not your concern, use OpenAI because right now it's cheap. We just think it will be more expensive because it's not maintainable with this cost that they provide. But if the privacy is the concern, you will have higher costs, but you will have the privacy of the data. So the self-hosted model is not for cost reasons. It's mainly for the privacy reasons.
Yeah, also about privacy, thank you for the presentation. But when you use openly available large language models, they do have bias inside them, right?
Yeah, they do, often.
So, and the question is, I guess, when you train them for your specific application, do you some way somehow remove this bias and to like make your large language model trained specifically for your application without a bias, and how do you approach this at all?
Yeah, thank you for that question. It's a very good one. So first of all, there of course is certain bias that may be involved in the model that is pre-trained and available there. It usually comes from the content of the data. There's are great efforts being made to actually cleanse the data of everything that may be influenced the behavior of the model in some undesirable ways. But yeah, this is something still of concern. This is something still not very resolved. But yeah, having a model that is slightly biased, with the opportunity to fine-tune, we present him with these different prompts, with different examples of behavior. And if you fine-tune the model with not on large enough data set, it is possible to actually reverse the behavior. Like the basic transformer has only ability to continue the sentence, continue the sequence of some tokens, but the way they phrase model is like 1 to 5% of the like costs and the data sets that the model is actually trained on. So yeah, this is relatively a quicker process and less expensive one. And we are, to be honest, I have never been involved in trying to, let's say, convince the model that is biased in from, like, maybe it's root, and you may want to make it more polite. I have never been involved in such a process, but I have been involved in training many models, and changing of behavior by fine-tuning is definitely an option. It's something that people do.
Okay,
thank you. Anyone else? Okay, I don't see anyone. If you are still interested and maybe you want more details, yeah, we'll still welcome you in our booth. Remember, iSoft is located in booth 39. Just go straight from that door and you will find us, no problem. And yeah, can I see my screen, please? Yep, thank you. First, I want to thank you everyone for coming here. Thank especially everyone who helped me develop this presentation and everyone who was involved with work. I unfortunately can't name everyone because there were simply so many people involved. But yeah, this is not a one-man project. I'm just the face of it at this particular moment. And I have one more thing for you. If you are interested in the very code that we used, we are sharing this code with you. You can either install it via PyPy. We made a Python package out of it, or you can visit our repository. Is on a license. You can use this code however you want. This is a valuable license, so feel free to use that. And if there are no questions anymore, then thank you for participation. Thank you for ability to and opportunity to speak to you. I feel very grateful for that, and have a nice day.